Now to continue with the previous class, we will see software development life cycle today. Why software development life cycle is important? Because you never know when you start doing things what would be the next step, and you cannot ensure that if you do particular thing in first step will definitely reach you to the another step, isn't it? So if you know the next step beforehand, you can manage yourself with all the activities so that you reach to the next step. So it's a stepwise, phase-wise modeling of certain model, which we call it as software development model, and there are various types of it, isn't it? Which suits to various software development paradigm, various requirements. Based on that, we have various models. So we are going to see that in the next video. Now we will see why this models are required and who is going to give us that model. It's a model given by certain organization who deals with software process and engineering. So CMM model, we call it as capability maturity model. So this model checks and benchmarks certain maturity of organization's software process, how far the software is working, how far it is executed in the particular organization, and how far organization is developing due to that particular software. So highest level you have is level 5. So initial phase level 1, level 2 requires certain requirement management, certain project planning, quality assurance. यो सबै गरेको छ भने चाहिँ level 2 को certification पाउँछ है. It's like that. So before we go to this deep of the CMM levels, let's see our basic functionality of SDLC, wherein it's a framework that describes the activities performed at each stage. Remember, each stage, that means it has various stages. Each stage ma what kind of activities you're going to perform, if it describes that framework, and it is called as SDLC. SDLC ma I have got it from the software lifecycle Hans ko kitab bada. So it says that there is a problem in any model. There is an identity problem. Once the problem is identified, once it is identified, it has to be communicated, isn't it? It has to be communicated to the group. Group does small level of engineering, which we call it as requirement engineering. Group has to go to the particular customer and perform a particular requirement analysis. Requirement ल्याउनु पर्यो. What is the requirement of that particular user? What is the requirement of that particular software? Software ले के गर्नु पर्ने हो भनेर चाहिँ requirement has to be collected. Then requirement is specification. We call it as specification of that particular requirement. तिमीहरुको मोबाइल को specifications or ल्यापटप को specifications, TV को specifications भनेको चाहिँ software को पनि requirement specifications हुन्छ. It has stages of collection, it has the stages of modularization, it has the stages of refinement and development. त्यो छ, त्यो document बनिन्छ एउटा. So that documents will tell you about requirement specification. Then once I have that particular document at hand, what I'm going to do is I'm going to design it. Okay, so design ma pani basic principles haru pura cha. Your design principles are, we must follow this design principle which is there as a part of life cycle model. Then once it is designed, after our design bhayisakeपछि what am I supposed to do? I'm supposed to give it to the team who does that particular implementation. Now your implementation गरेपछि एउटा system बनिन्छ, right? Which has different components on it, and each different component has to be tested. So system completely tested गर्नुको लागि each document has to be tested. then you find a working system. त्यो working system लाई चाहिँ के गर्छ तिमीले लगेर install गरिदिन्छ. It is installed in the particular customer's end. So customer ले के गर्छ regularly maintenance seek गर्छ. So that maintenance has to be provided by particular designer or a software firm that is producing that particular software. उनीहरूले नै गरिदिनु पर्यो. Now these are the basic steps. Requirement specification, design, implementation, right? Design, implementation, testing, and maintenance. Now let us see various models. First and foremost, easiest model is well-known model is waterfall model. Now you must see waterfall model ma what are the particular phases, what are the particular stages. You must know this: requirement, design, implementation, test, installation, and maintenance. These are the complete phase of your waterfall model. Now when you see this, it looks like a waterfall. It looks like a waterfall. Water is falling. Why we call it as a waterfall? Because it does not go back. I cannot go back. That means if I perform a requirement and go to a design, I cannot go back to the requirement again. I cannot go back. This is not permitted. Because it's a waterfall, no? It's falling down and down and down. It doesn't come back. Until we fit a motor there and water can come back. That's also there. Alright. Now let's see each phases of the waterfall model. Requirement phase ma ke huncha? It defines the needed information, functions, behavior, performance, and interfaces. We are collecting the requirement from the user. We are collecting the requirement from the software. What it is supposed to do, what function it is supposed to perform. Then we come to a design. Design ma we design a data structure. How are you going to implement our data structure? How are you going to keep our data? What would be the architecture of a software? What will be the interfaces design? कस्तो GUI चाहियो, कस्तो click clack कता के चाहियो, pick and drop चाहियो. Then finally we'll have a algorithmic design. अब त्यो चीज त्यो model लाई how am I going to implement it? हैन design मै identify भएको हुनु पर्यो. Then next stage is implementation, wherein I'm going to code. Implementation भन्ने बित्तिकै code हो. I'm going to code it. I'm going to design I'm going to create a database. I'm going to create certain documentations. I'm going to create certain testing plans. Then after that, what do we have? We have something called test, wherein I'm going to test. One is unit testing. That means all the modules can be tested individually. And another one is integrated testing, where all the model एकैचोटी टक्कै टेस्ट गरिहाल्यो सबैजना एउटा गरेन. वाटरफल मोडलमा के हुन्छ एकैचोटी one shot testing एकैचोटी. It doesn't go unit testing. So I install it in the user's end, then I start maintaining it. Right. So these are the various phases of waterfall model. Then we'll see what are the advantages of waterfall model. It is easy to understand, it is easy to use, it provides a structure to inexperienced staff. It's very easy. Structure follow, you can follow that structure and go away with start doing your project implementation. And milestones are well understood. Milestones in the sense all the benchmarks are well understood. I have completed requirement specification, done. Then you start what? Planning and designing. Then step by step phases are all understood. Then it sets a requirement stability, in the sense requirement are to be stabilized. Requirement has to be fixed so that I cannot go back again. Waterfall model good for management, plan, staff, and tracking. It works well when quality is more important than cost and schedule. Quality is more important. Our requirement specification ma 1 वर्ष लगाएर डल्लै requirement collect गर्यो भने दामी quality को software बनिन्छ नि. But we are losing what? cost and time. If it doesn't seek to understand, if it doesn't seek to go with cost or schedule, then you can go with the waterfall model. What are the deficiencies? What are the disadvantages? All requirement must be frozen. Right? सबै चाहियो एकैचोटि. Deliverables created in each phases are also frozen. एउटा design document निस्किने बित्तिकै that design document is fixed, so that it inhibits flexibility हुन दिँदैन. Can give a false impression of progress. Right? It shows that it is working. Where are you? I am in requirement मै छ, तर पनि it shows that okay, requirement हुँदैछ भन्ने it gives me a false impression, but it may not have been happening. It doesn't reflect the problem solving nature of software development. Iterations of phases. त्यो छैन. It cannot go back and do that problem solving हुन्छ नि. I find a problem and go back and solve it again. And I told you integration is one big bang, one shot. Little opportunity for the customers until it may be too late. Then when to use certain requirements will suit waterfall model. When to use it? We can use it in when the requirements are well known, when product definition is stable, when technology is understood, when new version of existing product has to be taken into market. Then when porting an existing product to a new platform, all that requirement ma chai waterfall model now huncha. Then the disadvantage of waterfall model has been improvised by a V-shape SDLC model. It's a waterfall model, but it can go back. It's a variant of waterfall model. We call it as V model, where we do verification and validation of a product. Then why do we need verification and validation? Because in one phase, whether we get the complete requirement or not, we don't know. We never know, isn't it? So each phases can be, we can go back to the phases again. अब यहाँ आइपुग्दाखेरि I will find that okay, some phases are not done. Then I can go down and go to this phase. Okay, I will do this. I can go unit testing. My problem here. Yeah, I came to know. Then I can go back to unit testing and I can go back again to designing, something like that. Testing of product is planned in parallel with the corresponding phase of development. See, all testing is happening here. Detailed design गर्यो, testing गरिहाल्यो. Architecture level गर्यो, testing गरिहाल्यो. Product requirement गर्यो, testing, accepted testing गरिहाल्यो. Yeah, so all that testing happens in the in parallel. So these are the phases. You can go through these phases. Firstly, it has to allocate the resource. Then secondly, it has to complete the specification of a software. Then it has to define how software functions and fulfilled in the design part. Then in a detailed design, we'll have an algorithm of an architecture. Then a production and operation we'll have to provide the correct enhancement and corrections. You can talk to each other, isn't it? So requirement correct bhayo bhayena, I'll have to check. Then in system and acceptance testing we must check the environment. फलानुको मा त्यो छ छैन, मेरो सफ्टवेयरमा त्यो चल्दैछ, उसकोमा त्यो चल्छ चल्दैन, all that has to be tested. Then when I go to a designing level, then I'll have to test the modules. I'll have to use a unit testing and I'll have to use the integration testing. Then when I go to coding, I'm going to transfer these algorithms into a software code. Alright, you can go through this. It's easy, very easy. Now, what is the advantage of V-shape? It emphasizes planning for verification and validation of a product in early stage of product development. Each thing is done, it is verified and validated. Each phase is performed and it is validated and verified. That is what is happening. So each deliverables must be testable. It's a testable one. We can track a process of every milestone and it is easy to use. But it has certain weakness also. It does not handle a concurrent event. Simultaneously event if I want to do design as well as requirement specification at the same time, requirement design, that's not possible. It doesn't handle the iterations at all. It does not handle also dynamic changes. Now I am at one phase and I find that there in requirement phase I am having a problem. I cannot go back to requirement phase and again do that. I can only do requirement and do requirement analysis, verify there itself. Once it is done, then I can go to next. It doesn't contain the risk analysis activities also. When are we going to use V-shape, this waterfall model? When you have an excellent choice for system requirement, right? Then you have all requirements are known. Then when it can be modified to handle certain changes which is required beyond the analysis phase, analysis punibiti, you cannot go back. And solutions and technologies are all well known. So I can use your V-shaped model. Then comes the next type of model, which is known as evolutionary prototyping model. Evolutionary prototyping model. Evolutionary in the sense, start from the small and build a big one. It's evolutionary. Prototyping in the sense, I will have a small working model of the big picture of my software. So here you need certain explanations here. Now, why developer needs to build a prototype? Why developer needs to build a prototype? Why? Because it can be tested, no? It can be tested. You okay hoina? Isto chaheko tapailai? If it is yes, then only I can go with the bigger software. त्यो एकैचोटि बिगर सफ्टवेयरमा पुगेर फेलियर हुनुभन्दा सानो प्रोटोटाइपमा फेल हुनु इज easier for us. Easier as well as in terms of cost and time, it is effective, isn't it? So in that particular thing, we do a prototyping model. All right. So it is there in the explanations. You can see this. Then how do we go about prototyping? Is we'll have a preliminary project plan. Right? First, initially we'll have a preliminary project plan. Then we'll have a partial high-level paper model. High-level paper model is created. It's not a big software we don't develop. We do it in the paper and pen and pencil. Then, with small partial requirement and with the basic and critical attributes, we built a small prototype. Okay, prototyping model mein stay huncha. We built a small prototype. The designer has to build the database, at least a GUI, small GUI, or algorithmic function is काम गर्छ भनेर, and the designer has to demonstrate that particular prototype. And the user evaluates for problems and suggestions and improvements. Then the user will see that prototype and say that, okay, bhai, yo yesto गर्नु हुँदैछ, तपाईले यो नगर्नुस्, यो गरिदिनुस्, something like that. And it continues, the loop continues until the user is satisfied. That's very, very important in today's life, isn't it? You go, you start doing things. If it does not satisfy the user, then you are a failure, isn't it? So it's better to have an interaction between the user and then say, keep on improvising, keep on changing the requirements and software. Now on the customer side, customer can see the system requirements. Developer can also learn from the customer, and it becomes more accurate end product, isn't it? It becomes more accurate end product, and unexpected requirements can also be accommodated, isn't it? And when I keep on talking to a customer, I may also develop that, okay, then customer will also be happier. Okay, low graded. That unexpected requirements can also be accommodated. It allows for a flexible design. Yes, it is a flexible. Then it's a visible sign for a progress, isn't it? If I keep on improvising the product, if I keep on improvising the every step of my software development, then it's a visible sign that my software will be better than others, isn't it? Then if any additional functionality is required, it can also be interacted. So this is advantages of the prototyping model. But then it has certain weakness. What are the weakness? Weakness is it has a tendency to abandon certain structured program, right? Code and fix development. It will have a disadvantage of having certain structured program. I'm losing it out. I'm taking much time before I go to development. I will be wasting time on some other thing, and it has a very, very bad reputation for quick and dirty methods, right? See, it's known because I do a small part of a big thing. Big thing may not be replicated to the small thing. Always it doesn't happen. It It cannot be done. It cannot be done. ठुलोलाई चाहिँ सानोमा रेप्लिकेट गर्नु it cannot be done. No? So सानोमै युजरलाई के गर्छ, युजरलाई फकाइ फुस्लाई गरेर सानोमा यो तपाईले यो चाहिएको यो म यस्तै बनाइदिन्छु भन्छ, खुसी बनाइदिहाल्छ, लास्टमा जाँदाखेरि चाहिँ it may not be that. So overall maintainability is overlooked. है माथि पुगेर ठुलो सफ्टवेयर how big it will be and what will be the maintenance cost, that's also unknown for us. And the customer is customer may want the prototype itself to be delivered. Customer feels that okay, prototype देख्ने they feel that okay, my software is done, I don't have to do anything else. So खुसी भइहाल्छ, happy भइहाल्छ. So उसको जति पनि requirement उसले जति पनि चाहने वाला थियो सबै दब्बेर बस्छ. It will not come out because prototype देख्ने बित्तिकै खुसी भइहाल्छ. Oh, this is what it is done. Okay, very good, very good. Yeah, go ahead भनिदिन्छ. So that is what is quick and dirty method. That's what is disadvantage of a code and fix development. Scope creep is what it is. The process of firstly analyzing the requirement itself may take long time. It may go further. फेरि लिएर गयो, युजरले भन्छ ओ दामी छ भन्छ, फेरि it can go on and on and on. So that is the weakness of your prototyping. You can go through this. Right? So before that, I will have to show you this. Yes, I'll have to show you this. Before that, I have already explained it. You can go through that. What is actually a prototyping is this diagram. This diagram. Okay, this diagram is your prototyping. This is a prototyping. What do? I collect a small requirement. I collect a small design. I do a small implementation, and I do a small testing. And go to the user. User ko ma. Then user, I will talk to users. User will be satisfied. Okay, you will be so happy. Right? You have made a great thing. He'll be so happy and say that, okay, go on. Then I will start with that small base. I will design a big one. And yo cha ma user la dekhaudina ni ta. That's the disadvantage. No? Here I may go wrong. I may go wrong here. In this particular design. So that is not known to the user. So it becomes so quick that user also feels that okay, then I'll do design implementation. This is a bigger one. This is actual software. This is a prototype. Alright. So I will erase this. So you can go through this once to understand how prototyping is done. There are two types of prototype. Throwaway prototype. Throwaway prototype means once a prototype is made, you go to user. User says this prototype is not. You do it like this. You will keep on adding things. Then you throw that prototype. Alright, you throw that prototype. You don't use at all. It's like a waterfall. Tala gayo. Tala पुगिसक्यो नि त हामी त implemented and tested पनि गरिसक्यो. अब उसले भन्छ यो नगर भन्छ फेरि माथि जानु पर्यो नि. We'll have to go again down and down and down. Evolutionary prototype is the best prototype wherein it says a prototype एउटा बनाउँछ, त्यो prototype लिएर जान्छ, त्यो prototype is made changes. Isn't it? All the changes are made to that prototype. त्यसैलाई फेरि के गर्छ? Evolve गराउँछ. त्यसैलाई फेरि evolve गराउँछ. त्यसैलाई better गर्दै लाँदाखेरि के हुन्छ? At the end, nth prototype will be delivered. So nth prototype becomes final software. Now next type of model is rapid application development model. We call it as RAD model. RAD model is a well known and fast and effective model. But then for that you need certain their own method of their own framework of software development you will have to follow. You don't have to follow software life cycle of waterfall. You don't have to follow prototype. But उनीहरुको आफ्नै हुन्छ RAD model. त्यो follow गर्यो भने चाहिँ what happens is requirements planning phase, workshop, utilizing structured decision of business problem. I go there, I talk to the business problem, I talk to them, I get certain discussions, I get certain requirement. Then next comes user descriptions phase. Automated tool capture information from the user. It's like I take certain instruments, go to the user, and automatically user le feed गर्दै जान्छ, मेरोमा सबै कुरा आइपुगिहाल्छ. Then construction मा चाहिँ I do very little, but do until it is done, until it is very ready to be given, isn't it? So in that particular thing, what do? We do use certain code generators. We draw a diagram here, right? We draw a diagram here, and to diagram को code generate गर्नु पर्यो है. I will feed that diagram into my RAD tool. RAD tool ले automatically के गरिदिन्छ, code generate गरिदिहाल्छ. Screen generators, your GUI creators, सबै कुरा अहिले छ नि, pick and drop, VB, NetBeans मा पनि त्यही हुन्छ, pick and drop हुन्छ, छिटो बनाइदिहाल्छ everything. Then finally is your cutover phase. Cutover phase means install. Go and install in the user system. गएर थालिहाल्यो अनि त्यही user कोमा गएर you do your acceptance testing and user testing training. त्यति बेला गरिहाल्यो. So it becomes easier, no? Rapid application development हो नि त. Strengths is, yes, cycle time is very comfy, right? Then we use a time box approach. Time box approach भनेको each phase are a time boxed phases. यति टाइममा म रिक्वायरमेन्ट सक्छु, यति टाइममा म युजर डिस्क्रिप्सन फेज सक्छु, यति टाइममा कन्स्ट्रक्सन सक्छु भनेर. So that's the strength, because it will cut down on cost, it will cut down on schedule. Then customer is involved throughout. I'll go to customer's place and then I start working. So most of your software engineers, like many of my friends also had gone to customer's place outside, कोई Delhi, कोई Bombay, कोई US, कोई UK, कोई France, कोई Australia. Why do they go is one of the criteria may be this also. So they go to the customer's place, they build the software there themselves, sit with the customer. So involvement is very, very high. So the focus moves from documentation to the code, directly from documentation to code. So this is the standard. You can check this standard in the web. Then you use various modeling concepts. You use various modeling concepts for a business, for a data processing, for a process identification, for model identification, creation of GUI, talking to the users, data collection, all that. You use certain ready-made models. So it's a rapid one. It's a quick delivery of a software. Then weaknesses, you may have assumed that it's accelerated development ho, quick response dinu paryo user unknown cha, user jandaina bhani, it's very difficult. Another thing is, when you go and start talking to the user for the entire development period of a software, what happens is risk of never achieving closure is bigger issue there. त्यसले भयो भन्दै भन्दैन युजरले भने त के भयो त्यहाँ बसेको छ बनाएको छ हुन्छ. And it's very hard to use with the legacy systems, because legacy systems are standard use गरेर बनाएको हुन्छ है. So हामीले आफैले के गर्दैछ, छिटो बनाउने ट्राई गर्दैछ, आफ्नो तरिकाले बनाउने ट्राई गर्छ. It may be very, very difficult to use it with the legacy system. So incompatibility issues आउँछ त्यहाँनिर. And it requires a system that can be modularized. Right? Then a developer and customer must be committed to rapid fire activities. The customer, if it is very lazy and he does not know about anything technology, requirement बुझेको छैन भने चाहिँ it's very difficult. It cannot be done. When to use RAD? Yeah, well-known requirements are users are involved throughout the life cycles and project can be time boxed. Right? Then you have a functionality delivered in incremental way. Then high performance is not required, where system go बेसिक रिक्वायरमेन्ट्समा बेसिक सफ्टवेयरको बेसिक युजर्सको निड्स फुलफिल गऱ्यो भने भइहाल्छ. इट डजन्ट रिक्वायर हाई पर्फर्मेन्स सफ्टवेयर. देन low technical risks, isn't it? Low technical risks, because whatever I have, whatever user have, I will use it. I don't have to go in the higher side. Then system can be modularized. If system can be modularized, if I have a RAT tool in one section, I have another RAT tool in another section, to do it a system एकचोटि बनिँदैछ नि त हैन. If it can be done, then I'll be using RAT tool. Then next important phase or important type of SDLC is incremental. Incremental is partially affiliated with your prototyping, isn't it? Prototyping. But here the phase of validation and verification comes into picture, right? How does we do it? We construct a partial implementation of total system. It's a prototype, यो भनेको prototype हो, which you have already studied, right? Then slowly keep on adding the functionality. We keep on adding the functionality, and finally what happens? A very good software will be delivered, if we follow these two phases. The incremental model prioritizes requirement of a system and then implements them in a group, isn't it? What are the prioritized requirements I'll have to implement? That is taken into care by your incremental model. Then each subsequent release of a system adds function to a previous release until all design functionality has been implemented. So you can see this. These are the incremental phases. Increment N ma ke huncha? We have a detailed design, we have a code, we have integrate, we have implementation and maintenance. But before that, what do we have? We do study about the feasibility of a system. Then we do plan, we do requirement, and we do design. All the phases. Look at the phases. We do feasibility. Yes, it is feasible. We do plan and do requirement analysis. Yes, once it is done, I go for a product design. So product design takes place in a very, very slow way, step by step, incremental design. Okay. Then what are the advantages? It develops a high risk or major function first. Important aspects of a software is developed at the initial phase. It prioritizes, so each release can deliver an operational product, right? It's not type of prototype. Prototype machi inoperational huन्थ्यो, certain functions would not have been working. But then incremental मा के हुन्छ, टक्कै दिने बित्तिकै that is an operational model. तर उसले के गर्छ, फेरि यहाँबाट अर्को मोडल पनि दिन्छ, which will override that and added features हुन्छ त्यसमा. So beta version पहिला release गर्छ, then it will be modified, something like that. So customer can respond to each build. After each build it's a divide and conquer. It has a lower delivery cost. It has a product deliveries faster, very, very faster. Then customer gets important functionality earlier. That's what we've been talking about. And the risk of changing requirement is reduced. Now, when not to use this weakness, this incremental model? When it requires a good planning and design. Basically from the first, if I have to do it, then I will not be using incremental model. When it requires an early definition of a complete and fully functional system, I will not use it. And if I have a well-defined module interfaces, then I can use the other kind of softwares, but not software models, but not incremental model. And the total cost of complete system is not lower. Total cost of complete system is higher in case of incremental model, because I keep on adding. I keep on adding 10,000 को यो गर्दियो, then फेरि 10,000 को अर्को हाल्दियो, फेरि 10,000 को अर्को हाल्दियो. Then what happens? It's the complete system को त 1 लाख रुपैयाँ पुगिहाल्छ, हैन? But then complete system waterfall model or prototyping model मा टक्कै बनाउन दिइहाल्यो भने 50,000 मा बनिन्थ्यो होला, हैन? But it may not have all the strength of that particular software, which we would have done it using incremental model. Yeah, this is there. You can see this funding schedule. Let's go. Okay, problem solved. Then I can use this. Then I can use it upfront requirements. I can use it. then I can need a basic functionality चाहिहाल्यो मलाई चाहिहाल्यो मार्केटमा देखाइहाल्नु पर्यो भने चाहिँ I can use it. And if I have a lengthy development schedule, then also I can use this. And on the project which has a new technology, हैन एउटा बनायो अर्को टेक्नोलोजी आउँछ नि अब एन्ड्रोइडको अर्को भर्जन आउँछ मेरो सफ्टवेयर मे नट बी वर्किङ एट द्याट पोइन्ट अफ टाइम के गर्नु पर्यो वाटरफल मोडल बनाएको थियो भने त के हुन्छ त्यो डल्लै हटाउनु पर्यो देन अर्को ल्याउनु पर्यो फेरि तर इन्क्रिमेन्टल चलाउँदैछ भने के हुन्छ त्यो एन्ड्रोइड अर्को भर्जन आउने बित्तिकै त्यसको सपोर्टिभ टक्कै प्याच हालिदियो त्यो सपोर्ट गरिहाल्छ. Then next type of model is spiral model. We call it as spiral model because it has spiral. Look at the spiral. See, spiral. Spiral has 4 quadrants. Look at the 4 quadrants. Look at the 4 quadrants. Look at the 4 quadrants. The first quadrant has to determine the objective. पहिलाको feasibility study, plan, and then identification of a problem. Then I do determine objective of the project. Then I may have the alternatives, and I may have certain constraints also. So constraint based software machi spiral model chanu chahame. Then I keep on going. See, look at this. This is the way I'm going. I did this. Then if it is satisfied, I do the first quadrant. Then when I go to second quadrant, the same thing is evaluated. Same objectives are evaluated. Then if there is any risk, these risks are resolved and identified and resolved. Then a small prototype is developed. त्यो प्रोटोटाइपमा के हुन्छ भन्दाखेरि the prototype will have a development phase. Development phase मा के हुन्छ we'll have to conceptualize, we'll have to do the requirement analysis for that particular project prototype. And then I design it and I implement it, right? Then once I implement it, I can finish the project here itself, and I don't have to go travel all the spirals. I can finish it here itself. Now when I finish it here itself, what happens? The user agreed to this particular prototype. Now but then the user may not agree to that particular prototype. So what am I supposed to do? I will have to plan for the next phase. Next phase ke cha? I'll have to plan. And next phase also begin with the same thing. See, look at this. Same thing. Same garyo. Very prototype banayo. Add garyo. Then repeat the same thing. If I do this, then this becomes a spiral model. If you want to remember your quadrant first. Quadrant mein ke activities huncha. Then you can have a spiral kind of diagram here. Then you have a second quadrant by prototype. Continues till third quadrant prototype prototyping model ke huncha concept, requirement, design and implement. Then if it is not satisfied with that particular prototype, then I'll have to go for the next phases plan garyo. Then I go on next plan ko lagi pani repeat the same thing. So fourth generation language jati pani cha, all that RAD tool which we studied, it adds to a risk analysis. And what we're talking about is it's one by one. We are doing it one by one. It's a prototyping model, but then with added risk resolve. Each cycle involves the same sequence as of the waterfall model. So we have seen this in the spiral model. Now look at this. The quadrants, each quadrant I have explained here. Objective, alternatives, constraints ke huncha, right? Constraints in terms of cost, in terms of schedule. Then alternatives we can build, I can reuse, I can buy. Objectives you can say this. Then you have evaluate. What do you do is study the alternatives. Arko pa dami thiyo ki. Let us evaluate the alternatives. And risk. Is there any risk? Lack of experience, new technology, schedule is tight, poor processes. Identify those risks. If risks are involved, resolve that particular risk. Okay. Then next is your develop. We develop. Typical activities we start performing here. So create a design, review a design, start developing a code, inspect the code, test the product. One of the product is ready. One of the product is ready. So product लिएर गयो, त्यो product चलाउनु दियो, है? त्यो चलाउँदै गर्छ. If there is any problem, then you come back to the next phase, plan for the next phase. Next planning के हुन्छ भने again same thing, develop another project plan, अर्को पाराले गर्नु पर्ने यसलाई हैन. Then do the configuration management plan, then test plan, then installation plan, then again repeat the same process, same phases, repeat the same phases again and again. What is the advantage? Advantage is it provides an indication of risk, right? If there is a risk, resolve it. So it is earlier resolve of a risk. Risk in terms of various, in terms of time, in terms of cost, in terms of manpower, in terms of technology. के आउन सक्छ त्यो अगाडि नै रिस्क आइडेन्टिफाई गरेर त्यसलाई इराडिकेट गरिहाल्नु पर्यो. सो व्हेन इट कम्स टु रिस्क पार्ट नो पहिल्यै स्पाइरल मोडल चुज गरिहाल्नु पर्यो. तर स्पाइरल मोडल कन्सिस्ट अफ अल द बेसिक मोडल फेरि अब वाटरफल पनि छ, त्यसमा प्रोटोटाइपिङ पनि छ. User sees the system early because of rapid prototyping छँदैछ हाम्रोमा. अनि critically high risk functions are developed first. यो RAT tool use गरे हामीले है. Then incremental model चलायो. High risk functions are developed first. Then we have a design. It does not have to be perfect. Our design doesn't have to be perfect because each phase मा फेरि त्यसलाई रिपिट गर्दै आउँछ, right? So user can be closely tied with the life cycle steps. Early and frequent feedback from the user, we get it. Then cumulative cost assessment is also done frequently. Cost कति लाग्दैछ, we will be knowing that. When not to use, when it involves a large risk, low project भइहाल्यो भने चाहिँ let's not do it, or let's not do it when it becomes when it has a very small risk in the project, right? Then time spent in planning, resetting objects, doing risk analysis. If it is very high, big हुँदैछ भने चाहिँ let's not do it. I told you before. Then if a model is very complex, let's not do the complex. Let's not increase the complexity of a model. Spiral model itself is complex and त्यसको के अरे software development नै complex बनाइदिन्छ. So if your thoughts are very complex, then let's not use the complex model here. Then risk assessment expertise is required here, हैन. Risk analysis गर्ने मान्छे छैन भने let's not do it. Spiral may continue indefinitely. The spiral may not end, right? Then developer must be reassigned during non-development phases also, because phase-wise development गरिरहेको छ नि त हामी हैन. So non-development phase everyone is involved. May be hard to define objective, defiable. Then you have a verifiable milestones that indicates readiness to proceed through the next iterations. It may be very hard because you never know what will be the next milestone. You never know what will be the next phase. When I go and talk to client only, then I will come to know what is the next phase, isn't it? So let's not use spiral model when I do not have any verifiable milestones. When to use? Creation of prototypes appropriate. When cost and risk evaluation is important. When medium to high risk projects गर्दा भयो, then long term it's unwise because the potential change of economic priorities. Long term projects commitment दिनु भएन. Then users are unsure of their needs. If they are not at all sure about their needs, then what can I do is I can keep on adding the thing, no? So spiral model ले help गर्छ यहाँनिर. I can keep on adding the features and development phase, incremental phase of my product, and user will be happier to see that okay, that was exactly my need. Then when requirements are very complex, every requirement time लाग्दैछ भने I can use a spiral model, so that small part of it do it, and again do it the bigger part of it, again do it, something like that. Then when you have a new product in line, yes, we'll have spiral model because it keeps on changing, technology keeps on changing. Then when you have a lot of changes in particular product development, if you have a lot of changes are expected, then definitely go for a spiral model. Then we have agile SDLC also, which is not may not be part of your syllabus, but then we must see through it. Agile in the sense speed up. they have their own kind of life cycle. It doesn't follow the life cycle traditional AMRO waterfall prototyping गर्ने follow नगरेर they may skip, they may bypass certain steps of life cycle. So that's also possible in agile development. Agile भनेको fast, as and when it is required. If you want to do that, then we can do agile SDLC also. So it is very, very less formal, and it is reduced with scope. Time critical applications I will use agile development, and it is used in the organization which does not employ any disciplined method. If it is not procedural, if it is not scientifically procedures are identified, then I can use agile. Agile models are also there. You must know these models. ASD, FDD, DSDM, then RAD we talked about. Scrum I use garcha. Then extreme programming, then RUP is there. Now basic definitions of this programming, agile programming is there in this PPT. So you can go through this, but I will not recommend you to study agile SDLC, because if we know SDLC, we don't have to learn about agile SDLC. As in when those kind of requirements comes to us for software development, we can easily follow agile developments also, because after all agile developments also follow the same traditional methods of developmental cycles. Only thing is certain bypass can be done. Okay, so just go through this SDLC very importantly, because all the phases are important. We're going to do requirement, then we're going to do firstly we're going to do the feasibility study on problem identification, then we're going to do requirement, then we're going to plan it, then we're going to design it, then we're going to implement it, then we're going to implement garनुको बाद we're going to deploy it, then implement को बाद we're going to test it, then test सबै right भयो, then we're going to integrate in the one single system, then we're going to deploy it in the users, and then user, if they have any problem, then maintenance is done. So all this phase, all these cycles is very, very important in software development life cycle. You go through this once, and if you have any problem, you can just mention it in the WhatsApp group, or you can write it on the same YouTube this thing also, comments also. Okay, bye.